All right, Algebra 1. Notes. And we're going to be covering section 7.8. Factor completely. Factoring polynomials completely. So we've learned all these different methods. There's one more actually I'm going to show you today. Should be your name on your sheet, date, period. Okay, so there's going to be one last technique, but then we're going to kind of throw them all together. They're all going to be fair game. And this will be it. This will be the last one. So let me show you this last technique. Example 1. Factor by grouping. Factor by grouping. So we'll do a couple examples of this. X cubed plus 3x squared plus 2x plus 6. And do another one. X squared plus y plus x plus xy. Now, factor by grouping, if we look at these, none of the methods we've talked about would work on them because these have 4 terms. So factor by grouping is when you have 4 terms or even any even number of terms. So this would actually work on 6 terms or 8 terms, maybe. Okay, now it's not guaranteed to work just because you have 4 terms. Okay, the other thing you need to watch out for is that usually for it to work best, it needs to be in standard form. We've talked about standard form before. Standard form. So standard form is usually the highest power term to the lowest power term. Now that gets a little weird on B. We'll talk about on B. Now on A, standard form, x cubed, x squared, x to the first, x to the 0. If there's no x, that's the same as x to 0. This is standard form. So what we do is we look at the first 2 terms. And we take out the GCF of just those 2 terms. So we say, what's the thing we could divide out of both of those terms? Usually we've talked about GCF for the whole thing. Now we're just going to look at it for this pair, this grouping. Now we could take x squared out of both of those, right? And when we take it out, we're dividing it out. So if we divide x cubed by x squared, you have x to the first left over. Plus 3x squared divided by x squared is 3. Okay? Then we do the GCF for the second 2 terms. Okay, so plus, we need some plus or minus here. We take a 2 out of both of those. So if you divide a 2 out of 2x, you have x. If you divide a 2 out of plus 6, it's plus 3. Now, for this to work, either one, if you've done it right, or if it was set up right, or it's even possible, you should get the same thing inside both parentheses. If you don't, you either messed up, it wasn't in the right order to start with, or it just can't be done, which is a possibility. Okay? So if we get the same thing in both terms, I'm going to kind of think of the GCF again. I'm going to be like, this is the GCF. I can divide this out of both of these. Does that kind of make sense? Like GCF doesn't just have to be a single number or letter. It could be a whole chunk of stuff that we could divide. This is multiplication right here, right? So I'm going to undistribute the x plus 3. I'm going to divide that out of both of those. Now, what's left? Here, it's just an x squared. Here, it's plus 2. Okay? And then you always want to check if you could keep going. Like, could you, after on any of these factoring methods, whatever you get inside the parentheses, could you factor that more? Like this x squared, I mean, x times x. Can you think of 2 numbers that multiply together to get 2? 1 times 2, but This doesn't have middle term, so it's got to be that plus and minus form, right? I mean, if you're to try it, you get x and 1 and 2, and you get 1x and you get 2x, and they have to add up to 0x. There's just no way you can do that. So that's not going to happen. So this is it. That's your answer. You're done. Now, we could check our answer by foiling it. If you're not sure, and it shouldn't be like hard to do this, but if you got time on a test or something like that, just check it. If you made a mistake, it'll become obvious. So if you're to foil this, you do x times x squared is x cubed, x times 2 is 2x, 3 times x squared is 3x squared, 3 times 2 is 6. Do we get what we started with? Yeah, the 3x squared and the 2x are in different spots, but that's okay. So we did it right. Must be correct. Okay, now the next one, if I try and take out the pair of these GCF here, there's nothing other than 1, which could be a possibility. And this one you can take an x out, right? So this one's not really like ready to go. So this is where the standard form comes in. Standard form, I'm going to rewrite this. I'm going to put this in different order. There's different ways to think of it. You might be like, I want to get the x squareds. I want to get the terms with x's in it together, and the terms with y's together. You can do that. But this should work also. X squared is the highest power term. The next term, this is x the first, this is x the first, but usually you want to do the one that doesn't have the other variable in it. So this one's kind of weird. It has 2 letters in it. Then we do the x to the first that has the y. And then we finally do the one that doesn't have any x's. That's like x is 0 with y. So you're gradually going from pure x to pure y. Now, there's other ways you can do it. Like I'll show you in a second. But this should work. So GCF for this pair is x. You divide an x out, you get x plus not 0. X divided by x is not 0. They do kind of cancel each other out, but there's a 1 left over. Plus, GCF here is a y. And then you have an x plus 1 left over. We should get the same thing inside both parentheses. Otherwise, we can't do it or we messed up. So then there's an x plus 1. Right? We're going to factor this out, and then there's going to be x left over and a y left over plus y. You can check your answer by foiling it. If we fold it, x times x is x squared, x times y is xy, plus x, plus y. And that looks the same as this. That's the same as the first one. Just because if the terms are in different order, that's fine. Now, by the way, if we had rearranged this in like slightly different, if we had said x squared and then xy and then x and then y, that would actually work. That would be x plus y. Now, if you can't take anything out, when you're doing grouping, you should still take a 1 out because then that shows you the groups. GCF could be 1. Usually, if we're just looking at GCF, the whole thing is 1, we don't write it because it just doesn't do anything. But here, it's actually part of the process. So here you get x plus y, x plus 1. Same answer we got here, just different order. So, you know, it is possible you could get them in different order, but usually standard form, highest power to lowest power, 1 letter to the next is the best. So that's the one new technique. Okay, all the other problems are now going to just use everything we've used. So example 2. This says factor completely. So we're not just using a specific type of technique anymore. They're all fair game. You might use multiple versions in the same problem. Okay, so that's A. B is going to be 7x to the 4th minus 28x squared. So here's my tip though. No matter what, always look for the GCF first. It might be the only thing you do. And doing it at the beginning instead of later for sure makes it easier. So you always want to do that first. Look for the GCF first. So here, if you look at all these terms, 3, 6, 18, I'm like, oh, I could take a 3 out of all those, right? This should be x cubed, by the way. X cubed, x squared, x to the first, I could take an x out of all those. So my GCF is 3 for the numbers and x for those. 3 times x, 3x. Now I'm going to divide it out. If I divide this by 3x, the 3's cancel. X cubed divided by x to the first is x squared. Right? Divide this by 3x, you get 2x. Divide this by 3x, you get minus 6. Okay? Now, just because you did that or did any kind of factoring, you're not necessarily done. Can I go further with what's inside the parentheses? Can I go further? Well, this is a trinomial. We could try it. X times x. 6 would be 1 times 6 or 2 times 3. But I got to somehow get a 2x out of these. So if I had 1x and 6x, I'm not getting 2x. I could get 7x or 5x, depending on if one's plus or one's minus, whatever. 2 and 3, 2x and 3x would be 5x or 1x or negative 1x or negative 5x. I can't do it. Right? I can't get 2x in the middle with all these pairs. So this time, the GCF was it. And if you can't factor something further, we call that prime. It is possible you get a problem from the beginning that is as done as it can be. This one was pretty close. Okay, next one. GCF 728, I can take 7 out. Right? X to the fourth, x squared. I can take x squared out. Now, if I divide these out, 7x to the fourth divided by 7x squared is x squared minus 28x divided by x. 28x squared divided by 7x squared. X squared is canceled. 28 divided by 7 is 4. Okay? Can I go further? Oh, yeah. You remember this special one? This is a difference of squares. Difference of squares. This is what we learned in last lesson, but we also learned that we don't have to use this shortcut. But if you know the shortcut, it makes it a little faster. A squared minus b squared, something squared minus something squared is going to give you the somethings plus and minus, and you're done. You don't have to do that. You could do it, okay, x times x, 1 times 4, 2 times 2. You want to get a 0x in the middle, right? So you're going to want to go with the 2's. You do 2 and 2, 2x, 2x. Want to get a 0x, so one's plus, one's minus. Plus, minus. Same pattern, right? Don't forget the GCF. Don't forget the GCF. Don't forget the GCF. People just easily forget it. Maybe they think it's not even supposed to be part of the answer. Or maybe they just forget it. Don't forget GCF. GCF is part of the answer. Okay? All right. Let's throw something in that we've been seeing in recent sections also. So the other thing is that you might be asked to solve. Okay? Solve by factoring, which means you got to factor it first and then you solve it. The solving part's easy once it's factored. So you're going to factor it. Now, how do you know if you're supposed to solve it or not? Well, one, the directions might say like this. But it's also obvious that it involves an equation, right? An equation has two sides. On the left side, on the right side of an equal sign. These past problems didn't have equal signs. I put equal signs to say that this next step equals the last step, but they didn't start with an equal sign. These were expressions. You can't solve an expression. You can just change the way it looks, which is what we did. But an equation we could solve. We can get the values of x and make it true. But the first thing you want to do is it has to be equal to 0. Okay, it has to have an equal sign be an equation to even be able to be solved. But then to solve it, you want to move everything on one side equals 0. So it's not already like that. Let's move everything on one side, get rid of it. So this is going to be 2x cubed plus 8x squared minus 10x. I cannot combine this term with any of these terms. They don't have the same powers. I want to write it in standard form, lowest power to highest power, lowest power. Equals 0. You still got to write the equal sign equals 0. It doesn't make sense if you solve it and there's no equal sign. Now we got to factor it, okay? So GCF first. There's a 2 out at 2, 8, and 10. And an x. If I divide 2x cubed by 2x, I get x squared. Plus 8x squared divided by 2x, I get 4x. Minus 10x divided by 2x, I get minus 5. Okay? Can I keep going? Well, let's see if we can factor this. X and x, 1 and 5. I think we could do this. Write the binomials, x and x, 1 and 5. I need to get a 4x in the middle. Now, some of you guys might be getting to the point where you can just do this in your head. That's fine. If you need to write it out like this, keep writing it out. Now, we know one's got to be positive, one's got to be negative, multiply together to get -5, but they got to add up to 4x. So the 1x should be negative, and the 5x should be positive. And if these add up together for positive 4x. So it's going to be -1 on the 5 plus -1 on the 1 plus on the 5. Okay, so still got the equal 0. I think we're done factoring it. Okay, but now we're going to solve it. So this is where the solving comes in. You set each of these equal to 0. 2x equal to 0. X minus 1 equal to 0. X plus 5 equals 0. It's called the zero product property. Now I got to get the x's by themselves. Divide by 2 to get rid of multiplication. You get x equals 0. That's a root, a solution, an x-intercept. This one we want to add 1 to both sides. X equals 1. This one I want to subtract 5 from both sides. X equals -5. Now you're done. Now you solved it. So that's how we solve by factoring, which we've done before, but the problems are just getting a little harder. They might use multiple techniques. So let's do another one. X cubed minus 7x squared plus 12x equals 0. Okay. Everything's on one side equals 0, right? We're going to be able to solve it because it has an equal sign. Everything's on one side equals 0, so that's ready to go. So first step, GCF. I can take an x out of everything, right? Always do the GCF first after it equals 0. I can take x out. That's going to be x squared minus 7x plus 12. Can I keep going? Well, let's try it. X and x, 1 and 12, 2 and 6, 3 and 4. I got to get -7x in the middle, so I think I'm going to go with 3 and 4. Right? Now, don't forget the GCF. So we're going to write our binomials, x and x, 3 and 4. It's going to be 3x and 4x, and then you add -7x. So they got to both be negative, minus, minus. So that's factored. Then we set each factor equals 0. X equals 0. Done. It's an answer. X minus 3 equals 0. Gotta do a little work. Plus 3 plus 3. Next one. X minus 4 equals 0. Plus 4 plus 4. Now, you could always check these answers by plugging one of them in at a time to the original equation and see if it gives you 0. But that'd be a bit of work. So, I mean, this is what we're doing. Okay, so let's just try a few more examples, and then you're gonna try them completely on your own. So I want you to see if you could try these. So you can pause your video, try it, and then unpause it and watch together and see if you got it right. See if you got it wrong. Why you got it wrong? So here's one. Y cubed minus 9y squared plus y minus 9. Now, first thing I always look for is GCF. Is there anything we divide out? All these other than 1? Nope. Okay. But it does have 4 terms. So even number terms, we should try grouping. Now, is it in standard form? Highest power to lowest power? Yeah. Okay. So look at the first pair. GCF of the first pair is y squared. And there's a y minus 9 left. GCF of the next pair is 1 plus 1. Just write a plus 1. Usually if the GCF is 1, we just don't write it. But for this method to work, you got to have something out in front of this. Okay, did we get the same thing inside the parentheses? If we did, we're good to go. We either can do it or we didn't mess up. If you don't get the same thing, you've done everything right, then the original problem is the final answer. So now I'm going to factor the y minus 9 out. This is like your GCF now. Factor that out for the whole thing. There's a y squared plus 1. Can I go further? Well, I don't know. I feel like we've done something like this before. Y and y, 1 and 1. That'd be y1, y and 1. But this is, we need to get 0y in the middle. Well, the only time that's going to happen is if there's a minus here. Because if you look at this, there's no way to get, you can say, oh, one's plus, one's minus. Okay, but -1, +1 times -1 doesn't give you +1. So that's, we're done. This is it. As far as we can go. Okay. All right, let's try another one. 2, 36x to the 4th minus 4x squared. Pause the video. Try it. This is your shot. You need to see if you can do it. Okay, first step, GCF. 36 and 4, I can take a 4 out of both of those. X to the 4th and x squared. I can take x squared out of both of those. And I got a 9, x squared left, and a -1. Don't put 0 there, put a 1. Can I go further? Oh, maybe 3x and 3x. This is a difference of squares. This is 3x squared minus 1 squared. You could do the whole plus minus pattern, difference of squares, right? You could do that. Or we could just try it the other way, just the regular way. 3x, 1, 1, 3x, 3x. We need to get 0 x's in the middle. So one's positive, one's negative. This time it makes sense. It didn't make sense the last time. But see, +1 times -1 is -1. So that's good. And that's it. Don't forget the GCF. And we're not solving these. There's no equal sign to begin with. Okay, last one. X cubed plus x squared minus 4x minus 4 equals 0. See if you can do this one on your own. Now, right away, you should notice there's an equal sign. You're going to need to solve the problem. Okay, but you got to factor it first. Pause the video, see if you can do it. Okay, GCF of the whole thing, 1. Don't even bother. All right, 4 terms. Let's try grouping. Group, group. It's in standard form, right? Highest power, lowest power. That's kind of neat. GCF of the first pair is x squared. And then you get x plus 1. GCF of the next pair is -4. Now, we're going to take a 4 out, obviously. We're going to take a minus out, not even because these are both minus. If this first guy has a minus, put a minus here no matter what. Divide a negative out for sure. Okay? Now, when we divide -4x by -4, we get positive x. When we divide -4 by -4, we get positive 1. If you mess that up and you got -1 here, you would then or right away get stuck, or at least realize you made a mistake, because you need the same thing inside both parentheses. Otherwise, you either can't do it or you messed up, or it wasn't set up in the right order to start with. We get the same thing inside both. So I'm going to factor that out, x plus 1, factor that out, right? And then what's left is an x squared minus 4. Can I go further? Yes, I can. X and x, 2 and 2, difference of squares, however you want to do it. Right? 2x, 2x, needs 0x, one's positive, one's negative. So we factored it. Now you got to solve it. Solving's easy. Solving's easy. You just set each of these equal to 0, and you solve. All right, factoring's hard. Subtract 1, subtract 1. Subtract 2, subtract 2. Add 2, add 2. Those are your solutions. Only because that equals sign. Okay? All right. This is going to be it for our last section of Unit 7. So monitoring progress. Try it in out of your book. They're at the bottoms of the pages from this lesson in our book. It's on page 404. I'm going to do problems 1 through 8. They're at the bottoms of each page. Student Dynamic ebook. They actually have little videos for each of them that you can play. See if you got it right. Figure out how to do it if you got stuck. Check your answer. But it's got to be zoomed all the way out. So that's it. Try it yourself.